Welcome to I E Irodov solution by M.R. Chaudhary, Priyank Lal and Lavesh Srivastava. My name is Priyank Lal and I am going to cover electrodynamics unit of I E Irodov. So let's do the very first problem. Problem 3.1 states that calculate the ratio of electrostatic to gravitational interaction forces between two electrons and between two protons. And the other part of question is at what value of specific charge q by m of a particle would these forces become equal in their absolute values in the case of interaction of identical particles. So firstly do the first part of this question and here we go. So firstly understand the Newton's law of gravitational interaction. So F1, if you look at this figure, F1 is the force acting on mass m1 due to the gravitational interaction between mass m1 and m2, and F2 is the force acting on mass m2 due to the gravitational interaction between mass m1 and m2, and these forces are equal by their statement. And now let's look at the Coulomb's law of electrostatics. So q1 and q2 are two charges and F is the force between them, and the formula is equals to k q1 and q2 divided by r square. q1 and q are two charges and k is the proportionality constant which is derived from the Coulomb's law. So let's see the formulas used. So formula for our question is q square by 4 pi epsilon naught r square by electrostatic force, and for gravitational it's gamma m square by r square. Gamma is the gravitational proportionality constant, gravitational constant, and there is a q square and m square in this formula because we are dealing with identical particles. So let's calculate the ratio for electron first, then we'll calculate the ratio for proton. Okay, for electron, if you look at the formula here, so you just need to cut this r square and r square, so you'll get this desired formula. And now feed the values. So q for electron, as we all know, it's 1.602 into 10 raised to the power minus 13 coulomb, and this constant is nothing but, if you look at this k, so k is equals to 1 upon 4 pi epsilon naught. So if you feed this value, so it will be 1 upon 9 into 10 raised to the power 9, and the value of gamma, gravitational interaction constant, is 6.67 into 10 raised to the power minus 11, and this mass of electron is 9.11 into 10 raised to the power minus 31. So if you will calculate this, and I have verified it, you will get 4 into 10 raised to the power 42. So if you see the result, the electrostatic force is too huge then if you compare with the gravitational force. So now let's see for the proton. So for the proton, the formula remains same. The changes will be for the masses, and the charge for the proton is just positive and the value magnitude is same. So now let's feed the values. So now feed the values. So the mass will be different. So mass of an proton is 1.672 10 raised to the minus 72. So, and I verified it. If we calculate it, so it will comes out 10 raised to the power 36. So it's less than our previous result, but it's still huge. And why it is less? If you see this formula, this relation is inversely proportional to mass. If mass is going to increase, then this ratio is going to decrease. So that's what happened. And let's do the second part of the problem as I promised. So at what value of the specific charge q by m of a particle would these forces become equal in their absolute values in the case of interaction of identical particles? So what the problem demands? Problem demands that you just equate these two expression or the formulas for both the forces. So that's what I've done. So now put the expressions of this formula. So you just need to play around with the formula. So what I will do, you just cut this r square and r square. Oh, I can use a pen. So you just cut this and this, and you just take this part, this side, and bring this m this side, so it will comes out to be square over here. Now you need to calculate it. So we know all these values. We know 4 pi epsilon naught, we know gamma, so we just need to feed the values. So let's do it. So gamma is 6.67, and this 6.67 10 to the power minus 11, and this constant 4 pi epsilon naught is 1 upon 9 into 10 to the power 9. So if you calculate it, I have calculated it here. So the value comes out to 0.86 into 10 to the power minus 10 coulomb per kg. So to make these forces equal, you need a charge whose value should be equals to 0.86 into 10 to the power minus 10 for 1 kg of mass. So you can simply see that this electrostatic force is too much stronger than the gravitational force. So here I end the first problem of the electrodynamics unit. Hope you like it. See you in the next problem. Thank you.